Okay, as already has been explained, this is a typical box and whisker plot. You can see they've called this the third quarter, whereas I call it the upper quartile or upper quartile, and the first quartile is the lower quartile. Same thing, right? Something I may not have said is the difference between those two quartiles. We can look at what's called the interquartile range. Okay? As compared to the overall range, which is always the maximum minus the minimum. For each graph, you need to make 3 I notice statements. What I'm looking for is the fact that somewhere you talk about central tendency, right? When I say central tendency, I mean talk about the medians or talk about the means, i.e. the averages. That's central tendency. Somewhere you need to talk about the spread, and by spread I mean the range, the interquartile range, those two, how spread out the data is. And somewhere you need to talk about the shape of the data, and a good place to look is the dot plot for the shape of the data. The options for shape are descriptions like bell-shaped, uniformly distributed, skew to the left, skew to the right. That's a right skew. Right, lots of dots, as opposed to a left skew. Opposite way. It's the opposite way to what you think. It's talking in terms of the tail. Right, more dance moves. Here's a couple of brilliant examples of I notice statements. The key thing is you are comparing the two categories like gender or ethnicity or transport. That was the one I did, public or private. Whatever you compare the two categories and quote in your I notice statement the numbers that you're talking about. Notice in the statements they always quote the numbers with the correct units when they quote the numbers. Here's a classic. I noticed that the median height for boys is higher for boys than for girls. The median for boys is 180 compared to 165 for girls, a difference of 15. Very clear, quoted the numbers and even told me the difference. Big tick. Is that one to do with central tendency, spread or shape? Central tendency, because it deals with median. So that's one of my big ticks. Done. Here's another classic. I noticed the lower quartile for boys is 172 compared to 160 for girls. I noticed that the upper quartile for boys is 190 compared to 170 for girls. Actually, I think that one's only okay. It didn't really say, it just stated the values. It didn't actually say which was bigger, did it? Central tendency, spread, or shape? Spread. Could be spread or central tendency actually, but it is showing me how far spread the data is and comparing them. Okay, so a small tick there, and I'll be looking elsewhere for further evidence. In your notes, jot down these three words: average, shape, central tendency, spread, and shape. And this is another good point to make. Right, the next thing I'm going to say is very, very important. Well, this next thing I'm going to talk about is how to make the call when looking at two box and whisker plots. The top one that you're looking at now is dead easy. The box and whisker plots don't even overlap each other. You can confidently say B is greater than A. Better still, you could say it is highly likely that the population mean or median is higher than it is for B than it is for A. Moving down one. Again, it is highly likely that the population mean or median is higher for B than it is for A. Highly likely. Next one. It is probable that the population mean or median is higher for B than it is for A. As we move down, the medians are getting closer, right? And it's more difficult to know whether you can make the call. We have a rule of thumb that helps you to know when to make the call, how to make the call. You need to consider the ratio between the medians and compare that. When I say ratio, I mean the difference between the medians, as compare that with the difference between the lowest quartile and the furthest upper quartile. You'll note that that distance fits into that amount 4 times, about. And if you can picture with me, as those two medians get closer, it'll fit in more times in the overall spread. If it can fit in 3 or less times, you can make the call. Did I say 3 or less?
Yeah, 3 or more.
Okay, read this sentence. If the difference in the medians is more than 1/3 of the overall visible spread, so 1/3 meaning this is less than 1/3, because it's a quarter, this one, it's too close to call. The one I'm looking at is too close to call because it fits in 4 times. It has to fit in, it's actually less than 3 but more than 1/3. That is for a sample size of 30, right? This is true. This rule of thumb works for sample sizes of 30. This is proven theory based on the fact of many, many trials, okay? If you increase your sample size, we can narrow the tolerances by changing 1/3. Well, if you increase that to 100, that can increase up to 1/5. So in other words, the medians can be even closer together and we can still make the call. If it can fit in 5 or more times, you can make the call for a sample size of 100. Okay, that's what this says. Sample size of 100 has to be more than a fifth of the overall visual spread. We'd then be able to make the claim that A tends to be bigger back in the population. And again, increase the sample size up to 1,000, and we can make that tolerance even smaller, of more than a tenth. Okay, what you need to do now is copy down this picture and this sentence. Very, very important.